So the very first thing you have to know about critical points is the definition. And a critical point, intuitively, you can think of it as a place where there's a noticeable change in the slope of the graph. Like we're going along and suddenly something happens. But the precise definition is critical point is a place on the graph of f of x where either f prime of x is equal to 0 or f prime of x is undefined. So let's talk first about how to see them. It's a place on the graph of f of x, or better would be to say a point on the graph. So it's called a critical point because it actually has to be a point. You can see places where f prime of x is equal to 0 because that's going to be distinguished by a horizontal slope. So if I look at this graph, I'd like for you to stop me when I get to a critical point on this graph. I'm going to start my purple pen here. Stop me when I get to a critical point. Okay, right there is one, because I have a horizontal slope. Stop me when I get to a critical point. So lots of times people think, oh, it's only peaks and valleys. And peaks and valleys are a critical point. You know, the absolute top of the roller coaster and the absolute bottom of the roller coaster are both examples of critical points, but they're not the only kind. You can also have a situation where you're going down and you go flat, but you don't turn around. So I don't know what you would call this, but it's kind of like a waterfall. These would also be critical points. So I know you know what it looks like when f prime of x is equal to 0. Now let's look at what does it look like when f prime of x doesn't exist. So f prime of x doesn't exist. What you're saying there is I can't draw a tangent line in a way that makes sense. So if I look here and there's this sharp jagged corner, you're probably thinking, well, all right, if I look right here, I can draw a tangent line, no problem, because I can go back and forth. But if I went here and I was saying, all right, I'm going to draw a tangent line, when you go back, it looks like that. When you go forward, it looks like that. It's not coherent. So this would be a place where f prime of x does not exist. Where else would you see the f prime and other critical points? Yeah, at these sharp turns, you have places where f prime of x does not exist. Now, is f of x defined at those places? F of x is defined, it's just that f prime of x doesn't exist. Does the limit as x approaches that value exist? Yeah. So these are continuous at these points. They're just not, the derivative doesn't. You can have it where you have something that looks like this. You can have like a trifecta. So if this were x equals 1, you would have f of 1 equals 2. That's no problem. Would you have f prime of 1 being defined or not? What would you have the limit as x approaches 1 existing or not? Would you have, we did limits a long time ago, but
Oh wait,
if you look here, the limit also would not exist.
yeah.
Yeah, you failed the ant test. But the ant test doesn't give you the derivative. The ant test gives you the limit. So when we're looking at these two things, just be aware they're different. Even though they're both things that could be D and E, they're actually different ideas.
What if there was a graph?
So let's say that this is 1, this is 2, actually this is 3, and this is 2. Okay. So when you look at a graph like this, first of all, it's not continuous. Because to be continuous, you have to go through that point and just be able to continue on. So this is not continuous. But let's look at the three things we've looked at. So first of all, on this, does the limit as x approaches 1 of, let's call this q of x, does the limit as x approaches 1 of q of x exist? It does. If I look at the ants, I drew this too big, but like the ants, their antennas can reach each other, right? So the limit as x approaches 1 of q of x would be equal to 2. What would q of 1 be? Q of 1 would be 3. What would q prime of 1 be? Because these two don't match up, this is not continuous. But the reason that the derivative doesn't exist is because the derivative is defined in terms of this tangent line. Well, if I start here and I try to go backwards, I'm like, up, drop it up, that's just discombobulated. So the derivative doesn't exist because no tangent line can be drawn in a coherent way. So if you know that much, you know all you need to know about recognizing them visually, except there's one tricky point that's important to point out. So there's one tricky point. What do you do if you just have a hole? So here you would have a critical point at x equals 1, because it's a point on the graph where the derivative doesn't exist. What if you just have a hole? What if you look at something like this? So do I have a critical point here at x equals 3? Yeah, it's not obvious. And that's why it's important to feed in this definition really carefully. It's a place on the graph of f of x, or better would be to say a point on the graph. So it's called a critical point because it actually has to be a point. There's no point on the graph of f of x at x equals 3. So this is not a critical point at x equals 3, because in order to be a critical point, you have to be on the graph. If one of these were filled in, the point that was filled in would be a